Hi guys, Mr. Zigner. We're going to be looking at angles of polygons today. Now, a polygon is a plane figure, meaning it's two-dimensional, and it's made up of three or more line segments that intersect only at their endpoints. So you can't have crisscrossing lines and, of course, no curves. All right, let's get going. The first thing we need to look at is the interior angle measures of a polygon. So what is the sum of the angles in a polygon? Well, there's this formula right here, which we're going to look at. But to understand this formula, I thought we'd start with something we already know. How about a square? Do you know what the angles add up to in a square? Well, I guess it's important to know what each of the angles are, and that's 90 degrees. So all four angles are 90 degrees. And what's 90 times 4? Well, 360. Okay, so we already knew that a square's angles add up to 360 degrees. But now let me show you how the formula works, and it'll prove that it works, getting us this 360. So S is the sum, so the sum of the angles in this square is equal to n. Now what's n? N is the number of sides the shape has. So in a square, we have 4 sides. So that would be 4 take away 2 times 180. Okay, well, let's simplify that. 4 take away 2 in parentheses here would be 2 times 180. And what's 2 times 180? Yep, 360. So I just wanted to do that quick example just to prove to you that this formula does work. No matter how many sides the polygon has, we can use this formula to find the sum of the interior angles. All right, let's keep moving. So here's another example. Now they have that crossing sign for at a school. Now let's see how many sides. 1, 2, 3, 4, 5. 5 sides. So again, we're using that formula. We put in the 5, take away 2, times 180. 3 times 180 is 540. So the interior angle sum of a pentagon in this case is 540 degrees. Feel free to pause the video and look at this example a little more carefully. And here's another one. Now they want to find the angle of, one missing angle in a polygon. Now we've got this shape right here, 7 sides, and they only didn't tell us about one of them. So how do we figure out that one missing angle? Well, there's 2 steps. First of all, we have to figure out how much should these angles add up to. So we use that same formula, 7 take away 2, because it has 7 sides, which would be 5. 5 times 180, that's 900. Okay, so these should add up to 900 degrees. Now you can see what they did here is they added up all the other angles, which was 778, plus the extra one we're supposed to figure out, and that's supposed to be 900. A quick bit of subtraction, and you find out the missing angle is 122. Again, pause the video if you'd like to look at this one a little more carefully. Next, there's quite a few things to look at tonight. In a regular polygon, now what's a regular polygon? Well, all the angles are the same in the shape, and all the sides are the same length. Okay, so that's a regular polygon, and all the sides are congruent and all the angles are congruent. Did you know on Saturn there's a really unique cloud formation in the shape of a hexagon? Here I have a picture of it. Let me find that for you. There it is. So I would encourage you to look that up. It's really kind of cool how that cloud shape has formed in a perfect hexagonal shape. But they're saying, hey, what's the measure of each of those angles in the hexagon? Well, again, a hexagon has 6 sides. So our first step is to figure out the sum of those angles. So 6 minus 2 is 4. 4 times 180 is 720. So that's what the angles add up to in a hexagon. But what is each one of those angles? So that's a slightly different question. So what we do is we take the 720 degrees and just divide by 6. 6 is how many angles are inside of a hexagon. Well, that gets you 120. So that means each one of these 6 angles is 120 degrees. All righty. So here's another example, finding the measure of each angle. So it's kind of like the one we did with the hexagon for Saturn in a regular polygon. Here's the actual formula. It's the n minus 2 times 180, like we were using before. But now there's one extra step. We have to divide by n. And again, n is the number of sides. So we're back to the shape we already know. and that's our square. So what's the measure of each of the angles in a square? I think you probably already know. I think we mentioned it in the earlier example. Each angle in a square is 90 degrees. But now, if you bear with me, let's try using the formula to prove that it can get the 90. All right, here we go. So the number of sides, well, the number of sides in a square is 4. 1, 2, 3, 4. Minus the 2 times the 180 divided by n. Well, the number of sides again. Okay, on top we have 4 minus 2 is 2 times 180 divided by 4. Okay, what's 2 times 180? Well, that's 360 divided by 4. And what's 360 divided by 4? Yep, you guessed it, 90. So just showing you that this formula does, whoops, didn't quite circle that right, does indeed work to find one of the angles in a regular polygon. All right, so we'll watch for our directions as we try a few of these. One last thing to look at, and that's the exterior angles. So we already talked about this in a previous video. The exterior angles are formed on the outside of a polygon. And one neat thing, it doesn't matter if, like in this case, there's 4 sides or if there's 40 sides. All of the angles on the exterior of the polygon will always add up to 360. Again, it could be 4 sides or 400 sides. The exterior angles always add up to 360. Okay, we're going to be able to use that a little bit later. Here's a little table. Again, feel free to pause and check that out. I already pre-solved up to 10 sides what the angle sum would be. So that's kind of a neat table to have if you want to pause the video and write those down. All right, I highlighted a few of these to try out. Here we go. This first one, just have to find the sum of the interior angle measures. Okay, do you remember the formula for that? That's our n minus 2 times 180. If all we're doing is finding the sum, just this formula right here. Well, how many sides do we have? 1, 2, 3, 4, 5. So we take our 5 minus 2 times 180. Now let's try to shorten our video here a little bit and bring in the calculator to help us out. So that's 5 minus 2. Well, I can do that in my head. 5 take away 2 is 3 times 180. Now we'll bring the calculator back. So 3 times 180 is 540. There we go. So the sum of the angles in this pentagon, this 5-sided shape, would be 540. And you could have used the same formula on both number 1 and 3 here. I highlighted number 4 for us. So now it says, what are the measures of the interior angles? Well, they gave them all to us, didn't they? Oh, nope, they didn't tell us this one. All right, so here we go. Well, first of all, we have 1, 2, 3, 4, 5. 5-sided shape. And we already know what a 5-sided shape angles add up to from the problem we just did. So 5 minus 2 was 3 times 180 is 540. So I'm just going to bring that number over to this problem. So all of these angles should add up to 540. And that would equal, well, 135 plus 135 plus this 120 plus this 80 plus this x. Okay, let's get the calculator to help us with that part. So that's 135 plus, 135 plus 135 plus 120 plus 80. Okay, so far this adds up to 470 degrees, plus the one we don't know yet, and that equals 540. All right, well, it looks like we need to subtract this 470. So, wrong thing. So what's our 540 take away 470? There we go, 70. So 70 degrees is what x equals. There we go. So this missing angle right here must be 70 to help finish these angles up, adding to the total of 540 they're supposed to. Oh, number 6. Okay, what's the measure of each of the interior angles of this regular polygon? Okay, it's a regular polygon, and they want to know what each one of these angles are. All right, that was my n minus 2 times 180 divided by n. Okay, well, how many sides do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, here we go. So 12 sides minus 2 times 180 over 12. Okay, well, 12 minus 2 is 10 times 180 over 12. 10 times 180 is 1,800 divided by 12. Okay, let's bring the calculator in to finish up. What is 1,800? Too many zeros. 1,800 divided by 12. 150. Okay, so each angle in this 12-sided shape is 150 degrees. Super. Let's move on. In a pottery class, we're making a pot that's shaped like a regular hexagon. Okay, that's a six-sided shape. What's the measure of each angle? Oh, that's the same formula that we just used. So we start with our 6 minus 2 times 180, and we divide it by 6. Well, 6 minus 2 is 4 times 180 divided by 6. All right, let's grab the calculator to help us out. So 4 times 180 is 720. And 720 divided by 6 different angles is 120. There we go. So if we have a regular hexagon, each of the angles is going to be 120 degrees because 120 times 6 angles gets you 720. Perfect. I skipped a couple of these. Oh, here, we're going to look at this letter V. What do we have to do? Find the sum of the interior angles. Okay, so we're back to just finding the sum. That's the easier formula. Just n minus 2 times 180. But you've got to get the number of sides right. So you've got 1, 2, 3, 4 on top, 5, 6, the outer sides of the V, and 7. Let me double check that. So 1, 2, 3, 4, 5, 6, 7. Yep, 7 sides. So 7 minus 2 times 180. That would be 5 times 180. Look at me moving the parentheses around. And 5 times 180 is 900. There we go. So this letter V, if you added up all these angles, if we got a protractor out and measured everything, those angles would add up to 900 degrees. All righty, let's see what else. Oh, going to look at this one. Can an octagon have interior angles that measure, well, all these numbers? Could those add up to be an octagon? Well, I guess it'd be important to know how much the sum is of an octagon's angles. So let's find that out first. Well, an octagon is 8 sides minus 2 times 180. So that would be 6 times 180. So what should they add up to? 6 times 180 is 1080. Okay, 1080. So these should add up to 1080. All right, well, let's find out. Do those numbers add up to 1080? Okay, here we go. Let me clear that. So 100 plus 156 plus 125 plus 90 plus 175, 134, 160, and 140. Did I hit the plus sign? Oh, look at that. Perfect. So absolutely, the answer is yes. I guess we could explain by saying all of the angles add up to 1080 degrees, and then we could show our work here, proving that an octagon should have angles adding up to 1080. All right, let's see what's left. Skipping these for now. Did I have another one? Oh, there it is. Yeah, I wanted to look at one of these with an exterior angle. Let me move my picture over here. All righty. So do you remember what I said earlier about exterior angles? No matter whether it has 4 sides or 400 sides, the angles always add up to 360. Okay. No matter what, the exterior angles of any polygon will be 360. So what do we have here? Well, we have 2 x's. So that's 2x plus, what do these three add up to? Plus an 82, 36, and 70. Okay, they add up to 188. All right, so we just need to solve this equation. So we subtract the 188. That cancels out. 360 minus 188. Clear that. 360. Take away 188 is 172. And that equals 2x. Now we divide by 2. Okay. And half of 172. So divide by 2. Oh, I hit times 2. Oh, my goodness. So that was 172 divide by 2 is 86. Okay, there's our x value. Now let's look at our question again. Find the measures of the exterior angles of the polygon. Okay, so I guess we could say, hey, well, there's an 86 degree, an 86 degree, a 70, a 36, and an 82. There we go. There's the measures of our exterior angles. And that was my last one. So thanks for tuning in to this brief look at interior and exterior angles of a polygon. Thanks a lot, guys. We'll see you on the next one. Bye-bye.